Hello Internet, welcome to fourth video of MERN Stack tutorial series. In last video, we reviewed GraphQL, its advantages over REST API. We implemented GraphQL Server with Apollo, explored in-browser IDE for GraphQL. Finally, we set up GitHub repository and started the version work control workflow. In this video, let's start off with completing the version control workflow with GitHub. So we have a local machine. On the local machine, we have a baseline version. That's what we're calling it as master. And we also have remote, which is the GitHub repository. When we start off with a new feature or any changes to the code, we create a branch from the baseline version and we name it. So for this example, we're calling it as branch A1. Once the branch A1 is all coded and tested, it is pushed to remote. So on the remote, a merge decision happens after review. If there are any review comments, the merge is not approved by the reviewers. It is sent back to developer. So the developer needs to incorporate the review comments and this cycle continues until reviewer approves the code to be merged. Once that happens, the branch A1 is merged with the baseline version on remote GitHub version. Next, when we are ready to implement the feature 2 on our local machine, the same cycle happens. We create the branch, we call it a different name, same merge decision happen. Once the merge decision is complete or it is approved, then the branch A2 is also merged with the baseline. However, there is an important stage before creating a branch from our baseline version. It's called as rebaseline. Rebaseline is pulling the baseline version from remote at that point in time and syncing our baseline version with that version. Now, why is that needed? Because typically multiple people and even multiple teams may be working on the same project and the same code base. So just for the illustration purpose, we've taken another local machine where another developer has implemented a feature in branch B1 and it is already merged with the remote GitHub in the baseline version. So here when we are starting with the branch A2, which is later than branch B1, if we don't rebaseline it, we will be losing out on all the code changes which are done as part of branch B1. And if we don't rebaseline and when we push it to the GitHub and if it is merged, it might even break. So this is the workflow. On our local machine, from the baseline version, we need to create a branch for new workflow, new features, new code versions. So before that, the first step is to rebaseline our local machine baseline version with the GitHub baseline version and create the branch. So let's do that now. On the VS Code, we are on the master. So there is an icon. We can use the IDE feature or commands. For the sake of simplicity, we can use this IDE features. So here, right next to the master branch, there is a synchronization. It syncs up the code between remote and our local machine. So I'll say yes, it is pinning. It is. We are not expecting any changes in this instance because we are the only one who is working and whatever code base we have on the local machine is same as it on the GitHub. So it stops pinning. Then the synchronization happened. Click on the master, click on create new branch and give the branch name as video 4 and click enter. It will take a moment or two before the branch is created. So now on the left hand side you see this no longer master, so we are now on the video 4 branch. So here also on the terminal, right now it is showing as master because we didn't refresh the terminal. Let's refresh it and just say clear, and you see the branch is displayed as video 4. So now we can get started. We are on video 4. We need to implement the GraphQL schema and resolvers, at least the draft version of it, for the book club project. So before we start implementing the actual schema and resolvers, we need to refactor the code we have written. The index.js is the entry point for Node.js application. It is supposed to be for hooking up different components of the application and configuration. The actual implementation, such as this GraphQL schema and resolvers, they need to live in their own files. So let's first create a separate folder for GraphQL. And in the GraphQL, we have this typedef and resolvers. So this typedef or the schema of GraphQL server is independent of the actual backend or database implementation. So let's say in future we want to change the backend implementation. We want to change the database for an example. Then all we need to do is change the resolvers. The schema or typedef shouldn't or wouldn't change. So for that separation of concerns, we need to have this typedef in different file and the resolvers in different file so that the maintenance of the code is easier. So toward that goal, within the GraphQL folder, let's create two more folders. One for typedef, and within the typedef, let's create a file. We'll call it as index.js. So in this index.js, let's take out the typedef and copy here. Then we need to expose this to the outside world. That is done by module.exports, and we are going to export the typedefs. Then let's go back to the GraphQL and create a separate folder for resolvers. In the resolvers, let's create a separate file with index.js. So let's go back to the index at the root level. We have the resolvers, and the resolvers need to have access to the mock data. So let's copy both of these, the mock data and the resolvers, and go to the index in resolvers. And here we need to export only the resolvers. Let's save it. And on the index.js at the root level, now we need to import the resolvers and typedef from the GraphQL server, GraphQL folder, excuse me. So first let's require, and because these are our application code, we need to give the full path or the relative path. So we are at we need in the same folder, in the same root folder, we need to go to the GraphQL and we need to go to the typedef and call it as typedef. So notice we didn't actually have to say typedef.index.js. That's because if we don't define the actual file, then Node.js will look for index file within that folder. So in Node.js will go to the GraphQL folder and then typedef. Since we didn't define a file, then by default it will go to the index. It refers to index.js file within that folder. Had we named that index.js to something else, then we have to give that file name also. Similarly, let's get the resolvers. Is equal to require same GraphQL and resolvers. So again in the resolvers also we called it as index.js. So we don't need to give the full path. Now let's go to the command prompt and run node index.js. So Express server is running. Okay, let's refresh our GraphQL playground IDE. Let's go to schema. We still see greet and get books queries. The schema looks correct. Let's run our greet query. Okay, it still works. Let's try the second query, get books. Okay, there is an error. Let's go and figure out what that error is. The error is we didn't complete our query as it is given with this weekly line. So it needs to have, the book should have a field. So let's say ID, title, and let's rerun. Okay, so we get the query back. So the code refactor is successful. Now we need to implement the schema and resolvers for our book query application. Let's start creating the schema and resolver for our project book club. So on the browser, the next tab, I have the prototype open. If you recall, in the video one, we had detailed walkthrough. So let's review this prototype page by page and extract the schema needed to satisfy these views on our book club project. So on the landing page, we have a hero section which is static. Second view is books in the club. This requires a list of books to be extracted from the database. So for this, we need to have a query which supports this view. So coming to the typedef index file, let's remove the test queries we had created and also remove this book. So the first query what we need to have is to satisfy the list of books. So let's call that query as books. It should return an array which is represented by the square brackets, and it should return each of those elements within those array should be of type book. We need to now define what that book is. So again, let's create a one more row type for book. And let's examine the card and identify the elements or attributes each book type should include. First is the image. Let's create an attribute for that. It's called as image, and we will be supplying the URL to this image from GraphQL. So the URL itself is a string, and by the business rule, the book should have an image. It should be mandatory. It is not allowed to be null or absent. So that can be enforced in the schema with this exclamation mark. This is non-nullable field. Next, for the book, we have a title. So let's write title. It is also of type string, which is not nullable. Then we have an author. To start with, let's start with author as string, and it's also not nullable. We may need to come to this a little bit later, but for now, let's start off with author as type string. Then we have these two tags, one for genre and one for rating. So again, genre is a type string, which is also not nullable. And let's come to the rating. Rating is of decimal point. It can be one place after the decimal. So it is of type float. So a book without a rating is a valid business case. So we will not include that exclamation point here. I think these attributes cover the view of books on this page. So the next step of the workflow was to see a details of the book by clicking on this card. So let's see. On the details page, we have the title, we have the author, we have the image. What we don't have on the front page is this description. So we need to have another attribute on the books for description. It is also of type string, and every book should have a description. So we'll make it as non-nullable. And there are genres and there are ratings. So I think this is the first draft version of book attribute. We will come back to it as and when we start implementing the resolvers and start covering all the views of the application. So let's save it. Now let's go to the resolvers. So we don't, this mock data is not relevant. So we have to delete this test query resolvers. So we need a resolver for books because that is the query we have in the root query. So in the books resolver, it's an arrow function, and we will just return the mock data for now. For first few initial iterations, we will use the mock data, and obviously when we implement the MongoDB database, this data will not come from this mock data on the file, it will in fact come from database. So to test this out, we need to have a mock data. So I have simply created a mock data which I'm going to copy here. It is mimicking what attributes a book type is. So it has image, title, author, genre, rating, and description. We have image, title, author, genre, and description, and rating also in the second book. So let's save it. Now let's terminate the server and restart it. Okay. So Express server is running. Let's go to the play area. Let's refresh the IDE. Let's see the schema. Now the schema is reflecting the only query which we written just now and the book type. So let's run that query now. Let's remove this and we have a query. Press Control space bar, you get the type of queries you have available here, and books should have an image, a title, and an author. Okay, so we are getting the values what we have in the mock data as per this query. Now, coming to the second page, this book details. To display a specific book details, we need a query which returns a specific book. So let's define that query. Let's call it book because it returns one book. So it returns a book. So to identify a book, we need a unique identifier, and that unique identifier needs to be passed to the query. So let's call a parameter ID, and its type is capital ID, which is a primitive type. And we can also give that exclamation point here, meaning when we are firing this query book, we have to pass ID. If it is not passed, then the query will fail the validation itself. So that means we need to define that unique identifier on the type book as well. So let's call in ID. This value is also ID and it is not null. So let's save this and let's go to the resolver. So we need to make uh, edits to our mock data. So let's call this ID 1, first book, ID is 2, the resolver for book, and let's write an arrow function for it. So we need to access the parameter which is passed in the book query, which is ID. So these resolvers get access to 4 positional parameters. The first one is called our parent, second is arguments, third is context, and fourth is info. So let's first console log and understand what are these 4 parameters: parent, argument, context, and info. And just return. So let's save it, stop the server, and restart it. So the server is up. Let's go to the playground and fire that book query, and let's observe the console log. So query, we want to fire book and it needs a parameter of ID, and let's extract title and author. So here we get the null because we didn't write the resolver function. Deleting all console logs. Also, we are not using info and context, and the arguments, let's do in place deconstruction and extract the ID. The first positional parameter, we are not using it, but we have to specify because it is positional arguments. Let's call it as underscore. That's the standard notation for positional arguments, which we are not using. Use the underscores. So we need to define the return value. Let's call it book return. Then we need to extract the data or the specific book as per that ID. So we have books in mock data. Let's use the find function on the array to get book which we are interested in. Each element in the book is each item in a mock data is a book, and the condition what we are looking for is book.id should match with the ID parameter. Then the ID which was the book which is found needs to be returned. Let's save it, and on the terminal, Control C, and let's run it again. So Express server is running. Let's refresh the ID. Again, run the query for book 2, and we are getting book 2 title author 2. This is as per the mockup. Let's test with book 1 as per the ID 1. So on the result we see book 1 and author 1. So we will stop our coding here. Before that, what we need to do is we need to take care of the version control. So on the left hand side, we have this first one is for file. So this is for version control. So for version control, we can first commit all the changes what we have made. Let's give a message of what this code change or branch contains. So book schema and code refactor. Press enter. Okay, all the changes are committed. Now on the left hand side, we can push it to the Git. The video 4 branch will be pushed to the remote. So on the browser, let's go to GitHub. Going to the branch, the repository book club backend. Okay, so the video for upload is done. You can see on the GitHub, we have a new branch, video 4. So let's compare and pull the request. So this is where the merge happens on the GitHub. So whatever message and comment we put in the branch on the VS Code that appears here, then as a reviewer, we can see what changes we have made with this green and red. The red meaning we deleted from the previous branch and green meaning we added it. So after the review, let's say create pull request. If everything looks good, then it does automatic compare. So if there are any conflicts here, those needs to be resolved. So in this case, there are no conflicts. So let's confirm the merge. Okay. So the merge is complete. So now uh, the backend, if you see here, the main branch has, or the master branch has all the code changes which we did for this video 4 also. So in preparation to the next video, what we need to do here is on the VS Code, let's go to the master branch. Now the master branch in VS Code that is on our local machine is one commit behind the GitHub. So GitHub has video 4 now, and this master here on VS Code is one step behind. So let's sync up this master. Let's say okay. Okay, the sync is done. So let's just see on the we are on the main branch, some master branch. Here we can see the GraphQL folder, the node changes, index.js, the changes we did here. So now the master here on local and remote are in sync. So in next video, we will start off by spinning off another branch from this master. That's it for this video. In next, we will continue to build the schema for our book club project.